Hello, my name is Dr. Ajay Kumar, PhD. It looks like I'm recording with the right microphone. This is, I guess, Flappy Bird 4. So, let's see, what have we talked about already? So, last time we talked about how the ticker works and how the pipe logic works. So, let me pull back observer up. So we gotta talk, so I think I'm gonna go sort of down the tree. So we talked about the bass, the pipes, and I guess right now we'll talk about the bird. The controller is probably maybe the most complicated of the three. Talk about the controller, then we'll get to the GUI, and... Alright, so let's talk about the bird. Then there's these other things like collision and sprites, but those are not processes, they just export functions and go. I don't care. It's just read only. Okay, module FB bird, behavior gen server, export boost, play, game over, reset, angle R, chord, bounding box, wings, start link, init, handle call. Okay, so these are this is boost. I think that's to tell, that's when you hit the space bar. So when you hit the space bar, he jumps. That is boost. And it's just, I think, a key press event. It doesn't, yeah, it doesn't last if I hold down the space bar. Okay. Boost, play, game over, and reset. Angle R, I don't know what angle R is. Chord, bounding box, we saw that. Wings, I bet, is which position his wings are in. Angle R, that must be his rotation angle. I don't know what the sub R means. And then these are standard gen server. Experimentally, it seems high terminal falling velocity is good. So is low absolute. Okay, I was clearly way too far in my head when I wrote this. Terminal falling velocity. So he must... So that's how fast he can fall at most. And then terminal climbing velocity. So how fast he can climb. Mess with the amount of gravity. Wing tick milliseconds. Messed with how long the boost lasts. And the terminal climbing velocity. I don't know what any of that means. I think this made sense when I wrote it. Alright. Probably it doesn't. Okay, what matters is how these are used. It doesn't matter. I think this is when I was experimenting, playing around with the parameters to get it to be just the right amount of infuriating. Alright, so wing tick milliseconds. So every 80 milliseconds it tells it to switch the wing position. So wings and gravity. Okay, so those are, so he's flapping his wings at a different rate than he's falling. That makes sense. Okay. Boost Excel is minus 3.5. Okay, that makes sense. Reduce the gravity, not the ticks. Faster ticks equals smoother. Okay. Gravity ticks. Okay, so gravity... Ah, I see. So I was probably to change gravity, I would change how fast gravity update. So, do I have my... let me turn on a light first of all. And where is my drawing pad? Here it is. And where is the cable? Here's the cable. So, I'm going to give you a brief introduction to calculus in order to explain the logic of this. Fuck off. Alright. So, gravity. How does gravity work? The way gravity works is acceleration due to gravity is constant. That is the way gravity works on the planet. Okay, so maybe an experiment. I'm going to perform this experiment, and I don't have a camera. I do have a camera, I'm just ugly. So I have an inhaler and a pocket. I should not drop the pocket knife, but oh well. So the pocket knife is significantly heavier. The pocket knife is significantly heavier than my inhaler. And I'm going to drop them from the same height, and they hit the ground at exactly the same time. You can't see that. I think even if I had a webcam, you couldn't see that. But I dropped them from the same height. They have roughly the same aerodynamic properties. What this means is, you know this famous equation, force equals mass times acceleration. And so you tend to think about physics in terms of forces. So I have my, let me try to draw the inhaler. I have it right here. That does not. Okay, that's my inhaler. And then the pocket knife is kind of just like that. Okay. I have the inhaler, and I'm going to say the inhaler weighs 2 grams. I don't know how much it weighs. I'm not great with communist units. And the what is this called? Pocket knife weighs 20 grams. That's about right. Okay. The mass of the pocket knife is 10 times greater than the mass of the inhaler, but when I drop them, they hit the ground at the same time. And that's because the motion induced by gravity does not depend on the weight. Right. Now, if I were to somehow measure the impact force when the pocket knife hits the ground versus when the inhaler hits the ground, the pocket knife obviously lands with much more force or much greater kinetic energy. So kinetic energy would be Ke equals, I think it's 1/2 mass times velocity squared. That 1/2 might not be correct. Might just be mass times velocity squared, I don't remember. It's a quadratic, it's quadratic in velocity. The point is that kinetic energy is proportional to the mass, and, well, they hit the ground at the same time, going exactly the same speed, or have the same velocity. But if you measured the kinetic energy, so that your intuition would lead you naively to think the pocket knife would hit first, but what your intuition is telling you is that the pocket knife will hit the ground with more energy. And that's correct because it has more mass. But it's interesting that it's proportional to mass and quadratic in terms of velocity. That's weird. It's just a fact of the way nature works. And everything in physics, force is sort of, you dig into the math, the force is kind of a red herring. Really what the beautiful theory comes out when you start formulating things in terms of energy. Energy is more fundamental in a way than forces. But forces are a lot easier to explain to college students, and so, whereas kinetic energy, in order to talk about that, you need this whole thing called calculus of variations, which I'm going to write that term down. You should look this up. It's really cool. And it's a shame that not very many people learn it. Well, I think a lot of people learn about it. Go look up calculus of variations. That's not relevant to what we're talking about. What I mean is that my point with that experiment, which you can't see, but you can perform the experiment at home with, any 2 objects you have on your desk that are different weight. The difference is that if I drop here, what is something that is aerodynamically retarded? Okay, I have a gum wrapper. Okay, I have a gum wrapper. This is, the term is aerodynamically retarded. That does sound like a technical term, but I just made that up. Okay, if I drop the gum wrapper is a really thin sheet of paper. Now I gotta chew gum, damn it. Gum wrapper and the inhaler, well, the inhaler hits the ground way before the gum wrapper does, and the reason is because, unfortunately, there's this annoying thing called oxygen, or air, and that completely fucks up physics. And what that means is, so the way you'll hear this question is, if you drop a pound of leather versus, or what is it? a pound of steel versus a pound of bird feathers, which will hit the ground first? Well, if you actually perform the experiment, the pound of steel will hit the ground first, just because aerodynamically it's not retarded the way a pound of feathers is. And I should not. Anyway, the point is that naively we can just go with this simple model, which will match your visual intuition well enough, which is to assume acceleration is constant. Now, what is acceleration specifically? Acceleration is constant. And then velocity, so it is also equal to the change in velocity, the instantaneous change in velocity. Now, in the real world, we approximate this with a continuous time system. There is not really such a thing as continuous time. That's kind of a... It's kind of a... I don't know if there... That's not quite accurate to say that there's no such thing as continuous time, but it... boy, I'm going to go off into a long math tangent, and that's not relevant. But it's the instantaneous change in velocity. And what do I mean by this? Now, velocity is the change in position. I'm just going to use delta for change in position. Okay, so what this means, our algorithm is, every time we get a tick, actually we're going to get back a talk, what we're going to do is we're going to update our position, new position, equals the old position plus the velocity, and then new velocity equals the old velocity plus the acceleration due to gravity. Okay? And this is constant. Okay? And then I think when we get a boost, what I do is I change the value of acceleration. So acceleration becomes negative for a very brief moment in time. What else? I think that's it, and then it just changes position and velocity according to this system. So in this world, we're approximating a continuous time system with a really, really rapidly evolving discrete time system. Does that make sense? Okay, that's what's going on here. That's the logic. And, okay, go away. Discard. Okay, so gravity, that's how gravity works. Max angle in... What the fuck is a milliradian? 1 milliradian, that's 1,000th of a radian. Okay, is 0.57 degrees. This is before I got red-pilled about angles. Thanks, Wildberger. Angles don't actually make sense. They're a psyop by the CIA. So max angle in milliradians. 1 milliradian is 0.57 degrees. So the max angle. Okay, so this is saying what is the max angle that we can be. Okay, that makes sense. Probably there's like a fancy way to think about it, but I think most of this was determined by experimentation and, Chapadois. Good enough. This is the essence of Chapadois. So I didn't know about Chapadois. Chapadois is a term in Chinese, and I'm sure I'm butchering the pronunciation. But what it means is like half-assed or good enough. And so it's like that Communist China, that's like everything is Chapaduo. For instance, I think the subway system in Beijing runs on a pirated version of Adobe Flash that runs on Windows XP. Like, that's just beyond insane, but that's true. And this is the Erlang equivalent of running your subway system on a pirated version of. I don't even know how that would work, but I know that I think Adobe like issued a Flash update, or they deprecated Flash or something, and it shut down the subway, and there was like an error message everywhere about Flash, and it's like, your subway system runs on Flash. Are you kidding me? Everything in China is a ridiculous Ponzi scheme, and their biggest bank just had a debt to equity ratio of 1600. So that whole China nonsense is not going to last long. Now this is not relevant at all to Erlang. However, first of all, it's late and it's my channel. I can talk about whatever I want, and also, I did talk a lot about this with Greg Cannon on our podcast, which is on Rumble. And I don't know if it's on BitChute. It got stuck in processing hell. And then we just recorded one a couple days ago, maybe yesterday. And we talked for 6.5 hours. It was going to be a quick conversation. We ended up talking for 6.5 hours. And so I got to go rewatch that and make timestamps and edit out all the horrible things we said. But that'll be episode 7 of Math After Dark. I don't know when that'll drop, but I don't know. I've been trying a standing desk and not having a chair, and that's really great when you're working. It helps a lot with your back. But if I have to just stand here for 6 hours and listen to myself talk, I'm gonna go insane. So I gotta either abandon the standing desk thing or stand here for 6.5 hours, or whatever. There's like, this is why I don't edit my videos, is because there's like 10 times as much effort. They have to, right? You record 20 minutes of video, and that's 20 hours of editing. Probably it would be maybe 10 hours if I was really good at it, but I'm not very good at it. And also, I mean, I should probably talk about code. So we got our angle. So our max angle in milliradians is 400. I guess the 20, who knows? Okay, we know what this is. Okay. This is how far up can he pitch, and then the min angle is how far down can he pitch, I think. Okay, and then what the hell is the flap threshold? Ah, right, because if he's going down, he doesn't flap his wings when he's going down. He's gliding. That's right. So at a certain point, minus 400 is when we decide he's gliding. Minimum climbing, right? Minimum because remember, we're in this stupid coordinate system that has wrong orientation. So climbing is negative velocity. So minimum climbing velocity is minus 8. I guess pixels per tick, or I don't know. And then terminal velocity is what is the fastest speed that he can fall. So that's the because air resistance is proportional roughly. This is the idea, is air resistance is roughly proportional to velocity, I think. If you're a fluid dynamics person, I'm sorry. But air resistance is roughly proportional to velocity. And so if you're like skydiving and you fall and you're flying out of the plane, your air resistance is going to be proportional to the velocity. And so there's a point at which you hit terminal velocity, at which point the air resistance is pushing you up and gravity is pushing you down. And at that point, the forces, here, let me draw a diagram. Right. Go away. So you're here. That's my attempt to draw a person. You're skydiving, and air resistance is pushing you up proportional to velocity, and gravity is pushing you down at a constant rate, and once your velocity gets high enough, these two will be equal. You can no longer gain velocity due to acceleration due to gravity, at which point you hit terminal velocity. You can no longer fall any faster, and so I wrote in some terminal velocity for the bird. Then we include our header, which, okay, and then the bird width and bird height, that's just the width of the sprite, that's for the collision detection. Okay, and then there's some off by 1 errors. This is some correcting some off by 1 errors before they show up, which is max, what the hell is max xdiff? We'll have to see where these are used. Okay, tick absent, right, because I didn't write in gravity for a while, and so ticks for a while was just the wings. And so now the tick is, right, now we are doing modular arithmetic with the ticks, so, right. So there's three tick positions. Maybe there's 4 tick positions. There's downstroke going up, which is neutral going up, and neutral going down. So I think 1 and 3 are going to be neutral, and then 0 will be downstroke and 2 will be upstroke. Maybe it'll be something like that. Okay, that's probably how it'll work. Right, so we've got our wings. Wings are by default down, and they're up, down, or neutral. Our ticks, and our gravity ticks. And then the tick absent any qualification refers to the... God damn it! What is going on? Oh, I hit caps lock. Alright. X, Y... Okay, wow, this is a complicated state record. So x, y, yeah, right, velocity, acceleration. And the reason this acceleration is in the record and is not constant is because when we do the boosting, that momentarily changes the acceleration for probably a few ticks. Maybe what it does is it changes the acceleration for like literally a single tick. But it changes it so rapidly that it can offset gravity very briefly. I don't know, we'll have to see. Angle in microradians. Angle R, that must be angle in radians. Okay. Yeah, because what the hell is it called? Wix is going to want an angle in radians. Okay. Status, yeah, and the status was init, or have we started playing? Is the game over? Are we in the... Right, okay. API, let's go. Angle R, okay, yeah. So these are the things you can call. Okay, so angle R, stop everything, wait until I give you the angle. Coordinate, stop everything, wait until I give you the coordinate. Again, not a good way to program, but this is the way I wrote it, and I'm not a good programmer, so don't take my advice. Okay, I may have contradicted myself there, but who cares? It's not why you're here. You're here because you like listening to me talk about Chinese banking. Bounding box. Gen server call module bounding box. Okay. Boost gen. Okay. Yeah. So boost. Yeah. Boost is a cast. Wings is a call, which is to get the wing position. Play. That's a cast. Game over. That's a cast. Reset. That's a cast. All right. I need to take a deep breath. Startup. Start link. Gen server start link. Yeah, that's boilerplate. Init. Start up the wings. Set the ticks. Send a tick. Gravity. Start a new ticker. Here's your whatever. Set the tick speed. What the fuck is gticks? God damn it. How do I go back? Nope. Pound. God, son of a bitch. There we go. GTIC. It's GTOC. Right. The reason for this is because I need to be able to distinguish between talk and gravity talk. Okay. And I'm 100% sure that if I go back and look in the old code, I didn't code I coded the wings before I coded gravity. So that's why you would think gravity is more fundamental, but you'd be wrong. Wings flapping is more fundamental in H.A. Kumar world. All right. Water is really good. All right. Where the fuck am I? Let's go back. Startup. Okay. Yeah, okay. Send to GTIC. State equals, I wrote this in retarded notation. Ticks and GTICs. Okay, yeah. Okay, state. Yep. Handle call chord from state. Okay. Right, so just get the coordinate. That's very straightforward. Actually, that's not slow at all. Handle call bounding box from state. Chords equals do bounding box. Angle R equals angle in microradian. Right, so if you have something in centimeters, 100 centimeters is 1 meter. So if you have something in millimeters, 1,000 and you want to convert it to meters, okay, yeah, that makes sense. Right, wings, yeah, it just grabs the wings out of the state record. Y. What do you mean, Y? This is interesting that I have both chord and Y. That's interesting. I don't know why. And then unexpected, yeah, we know what that does. Reset. Reset resets everything except the ticks. All right, handle cast. God. How long is... Oh, 47%. Jesus, I need to get going. Okay. Handle cast, reset state. Okay, yeah, so it just makes a new state record with the default entries except for the tickers. Okay. Should move this case over to a function. No, you shouldn't. No, you shouldn't. Yeah, so when you get reset game over... Okay, so when you get game over or play, all you do is change the status. That's literally the only thing that changes. Boost. I'm curious how boost works. G-talk. Okay, we're going to have to see how a lot of this works. Talk, okay. Okay, those are our casts. Alright. Unboost. That's an... Son of a bitch. Okay. Okay. Handle info, unboost state. New state equals do unboost state, no reply new state. Handle info, unexpected state. Okay, tell warning, unexpected info. Okay, that makes sense. No reply state. Terminate reason state. Okay. Do bounding box. Okay, yeah, this is very similar to what we saw before. Yeah, max x diff. Okay. Okay, I'm not going to work out the off by 1 logic, but apparently I worked this out before. Yeah, I mean, it works. It works the way the last one did. So it's saying that x is between, I think it's inclusive, between this value and this value, inclusive. Y is between this value and this value. We'll have to see how the collision detection actually works. Okay, do unboost. New acceleration. Right, okay. This is going to be interesting. Do unboost sets the acceleration back to gravity. Oh, you know what? It's probably a hack. So what it does is it sends a delayed message to itself. Okay. I bet it uses Erlang : send after. I bet that's what it uses. Bet it uses Erlang : send after something. Okay. New state equals state pound s, a equal, yeah, change the acceleration, new state. Okay. Boost. Yep. There we go. What did I tell you? I am the smartest mathematician who ever lived, and here's why. Because I knew that I was going to use, or that my past self, who he used, Erlang send after. I'm a genius. Okay. Underscore equals Erlang send after unboot. That was apparently a macro I didn't notice. Self, yeah, okay, so send after this many milliseconds. Self, okay, info, that's naked message passing, that's what it is. Okay, so if I receive a naked message versus one that's all packaged nicely for Gen server, okay. Right. Set acceleration to boost. Okay, so set the acceleration to boost accel. Right, and so instead of gravity, instead of gravity pushing us down, we have boost accel pushing us up. It's like we're on a rocket. That would be a way to think about it. A rocket is exerting a constant amount of force. Yeah, okay. You get what's going on, which is for a while we pretend gravity is negative and it's boost accel. Yeah, so gravity is 0.7, which is downwards, and boost accel is minus 3.5, which is upwards. And so for a brief moment in time, so precisely for 100 milliseconds, or roughly, we are going upward. Gravity pushes us upwards at a rate of 3.5 pixels per, what is it going to be? Pixel per Toc squared, right? If you think about it, so a Toc is our unit of time, and pixel is our unit of distance. So instead of meters per second being your velocity or miles per hour or something, instead it's pixels per Toc. Well, if you want to know the acceleration, that's the rate at which velocity is changing, which is pixels per Toc, or meters per second, or miles per hour. Okay, which would be pixels per Toc squared, or meters per second squared, per open paren second squared, close paren, ms to the minus 2. Okay, you all done physics, I assume. Okay, set acceleration to boost. New state, okay, that looks reasonable. Right, okay, yeah, so change the acceleration, return the new state. Only gravity during play, right, if we're in the init state, we ignore gravity, and if we've crashed, we ignore gravity. The only time where we care about gravity or boosting is when we're in the play state. Okay. Do gtalk, state equals pound s, status equals play, gtex equals gtex, y equals y, v equals v. Right, here is the heart and soul. Here is what I was telling you about. Damn it, I wish I hadn't deleted that. Scroll back to whenever that was in the video, or maybe open it in a new window and look at them side by side. This is what I was telling you we were going to do. Right, okay. Is round, is that a built-in function? Yeah, it must be a built-in function. It's highlighted, so it's probably a built-in function. So new y equals round y plus v. Right, okay. New v, so new y, new position. Right. Change our, so our velocity is the change in our position. Our velocity is the change in acceleration. What is update? Why does that need to be its own? Ah, it has the terminal velocity built in. That's why. Okay. So this is right. Okay. Okay. So it's velocity with bounds, with limits. Okay, that's why. Okay. And then update angle. How is the angle? It must just be proportional to velocity. Sorry, I gotta make this font smaller so I can read it. Actually, you know what? We'll get there in a second. Let me blow the font back up. Okay. Not play. Okay, yeah. So if we get a gravity talk and we're not in play, just send back a tick. Okay. Okay, but anyway, we do what we said before. We update our position, we update our velocity. Acceleration is assumed to be constant except boosting, which can change it. Angle in microradians, we update that according to, yeah, it only depends on the velocity. So, okay. Alright, this makes sense. Update angle using linear interpolation between min-angle to linear interpolation. Okay, yeah, min-angle to max velo and max angle to min velo. Okay, right. Okay, right. I probably wrote this down on paper, and I might need to open up my paint again, and we'll see. Velo percentage is equal to, I shouldn't have had it be nu v, oh well, is nu v minus the min climbing velocity. Okay, you know what, I am going to need, okay, I am going to need to explain this. Okay, so, right, remember our positive direction is down because graphics is stupid. Okay, so we have our velocity, positive velocity points in this direction. Our minimum climbing velocity is up in this direction. So this is our min climbing velocity, and then right. Okay, minimum climbing velocity, and then our max terminal velocity and our actual velocity. So this is our range, and our actual velocity, let's say, is here. Okay, so we calculate this difference here. That's the first thing. And then divide it by the length here, and that gives us our velo percentage. So it's how far are we starting at the minimum. If we're traveling from the minimum to the max, how far are we along that trajectory as a percentage? Okay. Angle diff float. Right. Okay, and so what this is saying is, well, let's say that this ratio here, so I am gonna use colors. This purple ratio to the yellow ratio. So, and then I'm just going to say blue is equal to purple, oh boy, divided by yellow. That makes perfect sense, right? Blue is our percentage, so this is our velocity percentage. Okay, and what we're going to do is we're now going to sort of, do an affine projection of this ratio onto our min angle to our max angle. And we're just going to go, what is this difference? And we're going to start at mid-angle and go whatever. Let's say that b is equal to, that looks roughly equal to 0.6, let's say. So this means we are 60% of the way across. And so what this means is I'm going to go 60% of the length here, and that's what my angle is going to be. That's what it means by linear interpolation between, right, okay. So angle diff float, angle diff int, right, and so we're measuring in microradians, so we're pixelated, we're doing this float thing, and then, right, okay. Velo percentage times max angle minus min angle. If you think of these as vectors, x minus y is a vector that points from y to x. So this is the, if you think of these as vectors, this makes sense. Go watch my abstract algebra playlist if you aren't familiar with vectors. Angle diff int round the angle diff float, that makes perfect sense. So this has got to be like a kind of in a higher range. Okay. We subtract from the max angle. What the fuck? Because the... Oh, okay. Okay. That is why everything is stupid. Because it does angles the right way. So counterclockwise angles are positive. So it knows how... Wix knows how angles work, but it doesn't know how coordinates work. Lovely. Wix is just the most... You know what? I can only bitch so much about something that works, but Wix is just absolute. I mean, it's actually really nice in other language. It works really nicely in Python. When we get to the GUI code, you are going to see Wix does not fit Erlang at all. It is oil and water. Right. And here's an example of it, because it knows how to do angles correctly, but not coordinates, and so you have to do this stupid sign flipping nonsense. Okay, I'm ranting. Subtract from the max angle because the orientation switches. Positive velocity is downward. Okay. So I would think it would be the minimum angle plus... No. See now I think that this should be flipped. So let me go draw my diagram correctly. So this is our max angle. And this is our min angle. Okay. Okay. And our difference is this percentage time. That seems wrong. Okay, but it looks like it works. This is why you don't mess with sign conventions, kids, because you confuse yourself. I'm sure this makes sense, and I just can't figure out how right now. I'm sorry. Let's just define this as being correct and move on. I have no idea. It seems like these should be flipped. Okay, I'm not going to be able to get over this. Because this points, this is a vector Okay. This points from the min to the max. Okay. And so I have no idea. I'm sure that it made sense. Why? So maybe let's just, instead of getting all hung up on affine nonsense, let's just think about this very thing. Okay, if we have positive velocity, we are going downwards. But this should be min minus max. Right, and then you would take the min plus the min minus. Does it work out the same way? Maybe that's the trick. It works out the same way. Okay. Sorry, I'm going to make that really small. Okay. Here, let me write it as an equation. Max minus velo percentage times max minus min. And I want to see, is this equal to min plus velo percentage times min minus max? And it might be 1 minus the velo percentage. So this is hypothesis number 1. And then hypothesis number 2, I need a better way to notate this, would be min plus 1 minus VP times min minus max. So let's color this hypothesis in pink. I want to figure out why this works. It's going to bother me. Okay, and then this one, this is our yellow hypothesis. It's probably one of these two, if I'm going by my intuition. Okay. Do I just have, I must have just like plain white. This green is getting on my nerves. Okay, so this is 1 minus VP times max. I'm rewriting this as 1 minus VP times max plus minus VP times min. Okay. Okay, and it's going to be the yellow one, I can already see. So the yellow one, let me show you why it's not the pink one. The pink one is min, so the pink one is 1 plus VP times min plus minus VP times max. That's not what we want. This is wrong. Hypothesis number 1 is falsified. And it's going to be the one in the yellow. Okay, this one is no. So we get min plus min minus VP min. No, we want this, sorry, it's not the yellow one either, and actually it's going to be a different color. Let me show you what this is equal to. This is, so we get 1 of min, and then 1 minus VP of min from here. So this is 2 minus VP times min plus 1 minus VP times max. And this is because the orientation is backwards. This points from min to max, and we need something pointing from max to min. And so this will be correct if we, and I can outline the orientation, I can outline the intuition for where you come up with these types of formulas. The correct answer is going to be min plus 1 minus VP times max minus min. Let me show you. Yeah, okay, so you'll get a min here, minus a min here, and then plus a VP. So this will get you VP. God damn it. No, that's not right. One. I have no idea. I'm sure that there is a world in which this makes sense. Is it just min plus VP times max minus min? I don't know. It works though. And so there's a rule which is that if I'm sure it made sense when I wrote it, and I'm sure somewhere in the ether there's an explanation for this that makes sense, that isn't just that I'm spending way too much. This video is like way too long already. God damn it, did I hit fucking caps lock again? Okay. I had enough of you, drawing pad. Let's move on. 80%, we're almost done. Okay, and then this is the update velocity thing, so if we are less than our minimum climbing velocity because Wix has stupid coordinates, then we use our we have a terminal climbing velocity, a terminal falling velocity. Otherwise, we update the velocity according to the acceleration. Right, and notice that it matches on V plus A so that we don't get locked up here, right? We can never get locked. I think you can get locked in a climb, can't you? Yeah, you could get locked in a climb because the gravity is so much less. So what I'm thinking is that you could get more than 0.7 away from the minimum climbing velocity, and then gravity could never recover. This looks like a bug that just, it's like a Heisenberg in waiting. It doesn't matter though, because who cares? Here's your exercises. I'm gonna make these. Okay, your exercises are number 1 is figure out why the angle thing works. And then it might be that there's a different formula that works a little bit better, but it's updating so quickly that you can't notice. And then leave a comment explaining it. Because that doesn't seem like it works. Alright, and that's exercise 1. And then 2, what is 2? What was I just... either prove or disprove the idea that you can get stuck in boost lock. Is boost lock possible? If so, prove it. Prove yes or no. And then leave a comment explaining it. I hate, like, okay, the reason I'm asking you to leave a comment, I hate, like, when people go, oh, like and subscribe, And I tried doing that in one video, and it just, like, it insulted me to my core. Now, I am tempted to, like, ask people to like and subscribe, or I don't care about likes all that much, especially on YouTube. YouTube's a kind of, it's like MySpace right at the end, right at the beginning of the Facebook era. It's just, it's dead, or it's like Friendster. That's maybe. But I want to use Odyssey, and Odyssey will sync with my YouTube channel, but only if I get 300 subscribers. And I'm currently at like 10. I think I have 16 subscribers. Okay. I appreciate all 16 of you. However, it would make my life slightly easier and allow me to go on Odyssey, because I'm not going to... I already spend enough time uploading to Rumble. And Odyssey, I'm not going to learn... Odyssey also has some weird crypto thing that I don't understand. And so, what was I going to say? So, 300 subscribers, and then I can start using Odyssey. So, if you're not a subscriber, please subscribe just so I can get Odyssey to work. Alright. Let's go. Just so I can get Odyssey to work. Alright. Is boost lock... Yeah, those are your 2 exercises. Alright. Talk. Let's do the talk. Talk. And if I have not been recording this whole talk, I am going to shoot my computer. I have been recording. Okay. Talk. Still flapping the wings during a knit or play during game over do nothing. Right. So, not flapping the wings here. If I hit N, he is flapping the wings. Alright. Send back a tick, because why not? Do talk. I still have a piece of gum on my desk now. Thanks. Thanks, Internet. Send a tick back. So this is... Right. Other... this is the wing. Right. Without qualification, the talk is a wing talk. Send a tick back. Right. This is what I was talking about with the... I was guessing that down was going to be 0. Right. So new t is t plus 1 mod 4. That's exactly what I thought it was going to be, what I explained earlier, where you just cycle between 0 and 3 and keep incrementing by 1 mod 4. It's clock arithmetic, but with 4 hours in the clock. Maybe that's a way to think about it. It's a clock arithmetic with 4 hours, and at noon your wings are down. At 1 o'clock, your wings are out. At 6 o'clock, no. Say we're advancing 3 hours at a time. I'm gonna pick one scale. Noon, your wings are up. 3 o'clock, your wings are out. 6 o'clock, your wings are down. 9 o'clock, your wings are out. Noon, your wings are back up again, and then you just cycle through that. That's the way that works. Something like that. That's the way to think about it. New state. Right. Tick equals new t. Wings equals new wings. Tick equals new t. Wings. Uh-oh. Mucinex is wearing off. I just had one of those awkward things where you like try to hold back a sneeze and it doesn't quite work. And oh my god. Anyway, I need to finish this video. It's got to have been more than an hour. Yeah, new wings. Right, this is the wing tick. So right, so this is the ticks. Right, okay. G tick. Right, okay. And so the reason that this is factored out into its own function is because we remember in the ticks module you can tell it to reply to you with a special message, and this is saying, hey, I'm a gravity talk, not just a talk. I'm special. I'm a special gravity snowflake talk. Oh, winged... What the... Oh, okay. I think this should be, if angle is less than or equal to, that should be LE on line 258. So if the, right, so this is the idea that so when his angle gets steep enough, I'm going to try to get high. Oh, you can crash into the ceiling? That's annoying. Right, when your angle gets steep enough, you start gliding. That's all this means. Ah, okay. Wing talk of T. Does wing talk... This has a 2 argument. Okay. Right, so if the angle is greater, because the angles are correct but the coordinates are not. Gotta love Wix. Angles are correct and coordinates are not. So yeah, wing talk of 0, down, neutral, up, neutral, and then down, neutral, up, neutral. Exactly what I said. Then debugging. Alright, that's enough for this video. If you watched all the way to the end, congratulations, the founder loves you. I hope you have a nice rest of your day. I will see you in the next video. Thank you for watching and listening through all of that. I hope at least you learned something. And please, if somebody can figure out why the angle thing works, or maybe why it's wrong, or leave a comment explaining the boost lock. Is the boost lock possible? That seems like it's possible. Prove that it is with an experiment where you what you can do is set the velocity really high and then do a boost and then show that gravity can't overcome the boost. Something like that. Leave a comment explaining it. Oh, maybe not. Because, right, it won't let you accelerate out of the range. Right, okay, so it's not. Okay, it won't let you accelerate out of the range. That's why it does that. Okay, yeah, so that makes sense. Okay. Boost lock is not possible. I might have just been wrong right there. Please let me know if I was right. Alright, that's all I have to say. Thank you. The video's already way too long. Thank you. Good night. Goodbye. Love you.